Let's take a look at the speaker class that I have built as a demonstration. When you are defining a class in C++, you are going to use the class reserved word followed by the name of your class, whatever you're going to name it, in our case, speakers. And then you're going to have an open curly brace. And we're going to skip way down here. And then you're going to have a close curly brace with a semicolon. And then everything in between are your member definitions. First, we have our member fields. So you can see I have them defined here. And something important to note is when you define a variable or a field or your C++ class, you do not instantiate it. So I cannot set these equal to anything up here. They just have to be defined, and then later on we will instantiate them. Next thing we have, and also this is all under the private keyword, which means that these are only accessible by other members of the class. I cannot get to these from outside this class currently. Then we have the public keyword. Under here, I have all of the things that I want to be accessible outside the class. First thing we have are the two constructors. Now, not every C++ class is going to have a constructor or multiple constructors for that matter. In this case, I have two. I have a default constructor that I defined, and then I have a parameterized constructor. It is possible with C++ to not define a constructor, and it will build a default constructor for you. The issue is it does not instantiate the field members. It can give you some issues. All of our field members to basically empty strings, and then I've set wireless to false and volume equal to 0. And I'm doing this to ensure that if I instantiate an object from this class, if I don't use the parameterized constructor, if I just let the default constructor do its thing, then the variables have been instantiated and I'm not going to get garbage in my program. The constructor with parameters, what I'm doing here is I'm taking in inputs for each of the fields and I'm just setting the field equal to whatever is passed to the object when it's instantiated. I just took the name of the variable and added into it as in input, like I'm inputting the variable here just to keep track because I like descriptive variables and function names in my programs. Underneath of that, I have function prototypes. These are the functions that will be used in the class. I have one for set volume, I have one for set power, and then the rest return the values of the fields in the class. And you might ask, well, hold on, how does the program know what to do? Sure, you've given a name, but you haven't defined what the function does. And that's because in C++ with a header file, we don't define the function in the header file. We are going to put it in what we call an implementation file. And that allows us to do this thing called data hiding. I have my function prototypes here, and that's my header file. Let's look at the implementation file. I have speakers.imp.cpp, so speakers implementation.cpp. And if I go here, we can see that I have included the speakers.h header file. Now, when we include user-defined classes and header files in C++, we put double quotes around them. Okay, if we look here, I have an include statement, and this is a standard library that is included with C++. We use angle brackets. But for user-defined classes, double quotation. I include speakers.h, and then at compile time, the compiler will link all of these together, and it will know that these are the functions or the definitions of the functions that we define the prototypes for in the header file. You may also see here, I have defined the scope here of speakers set volume. The reason is because a user-defined class, it's just a scope, because I always get the question, do we have to type this out every time when we're doing function definitions in an implementation file for a user-defined class? And the answer is yes. That is why you will see speakers for every function definition in here. Looking at our speaker implementation class, nothing fancy here. I take in volume and in power for the two set functions, and then the rest I'm just returning the field member or the variable back to the program. That is my speaker class, the header file and then the implementation file for it. Those two together make up my speakers class. All right, let's take a look at speaker demo, which is the program we are going to use to instantiate our speakers class. First, we are including IOStream, which is allowing us to do console input and output. And we are, of course, including our speakers class here. Now, it's important to note with C++ user-defined classes, we used double quotes. And for included libraries, we use open and close angle brackets. So I've created an object of type speakers called mySpeakers. I'm passing it the value Sony, the model number, setting wireless equal to true. The initial volume is 30 and power is set to off. Also, not sponsored. This is just a random speaker I looked up, so I had some data to put in here. Then I'm creating an object of type speakers called other speakers, and this is just going to call the default constructor. The default constructor, if you remember, has settings of empty strings for any string, wireless is set to false, and volume is 0. Next up, I'm just going to output all the information. So this is all just to make the output look nice and neat and make sense, because I could just do cout, get brand, get model, get wireless, whatever, but that doesn't look very nice. And I'm very much of the mindset that you should make your output be as meaningful and look as nice as you possibly can. This is just to tidy that up, and I have specified the first line will say this is the parameterized constructor, so we can keep track of what's what. And then this is the default constructor. When this outputs, my speakers, you will see, has all this information when it outputs, and the default constructor will have mostly blanks. Wireless will be 0, and power will be set to off. Let's give this a run. And as you can see, here is our current speaker. It has our information that we put in. Now, this is a Boolean, so it's going to be a 1 or a 0. And we're going to fix that later and make that a little bit nicer. But for now, it's just going to be output as a 1 or a 0. You can see power is off and volume is set to 30. Down here for the default constructor, anywhere there was a string, it's just blank. Wireless was set to 0 or false, and volume is set to 0, just like the default constructor had. As you can see, we can take our class and we can instantiate it multiple times here, and then they're independent of each other. I can change the values in each of these objects, just like if you take a blueprint at the factory and you build a bunch of different speakers. Once those speakers are created, they are independent of each other and they can be controlled independently. And that's what we're doing here, creating multiple objects that we can manipulate independently. We have some output here, that's great, but we do have the ability to modify the volume and the power. Next up, I'm going to add a couple functions that allows us to modify the volume and the power for our speakers. What I have done is I have created two functions. One is called change volume. It takes an object of type speakers, and we are passing it by reference, and it takes an integer. I'm passing speakers by reference because we want to be able to modify the object in the entire program, not just inside of the function. If you remember, if you just pass an object normally, it creates a copy of that object and it makes the modifications inside of a function. And then once that function exits, those changes are not applied to the original object, just to the copy. Passing by reference, we're actually passing the original object in and we're directly modifying that original object. In this case, we're passing in the speakers and we are setting the volume. So when the function exits, the volume of my speakers that will pass it will be changed. Same thing for change power. We're passing it an object of type speakers by reference, and we're passing it a string. And the string we're going to use is just on or off. So if we come down here into the program, after the initial outputs here, I have called the functions change volume. I've passed it my speakers and other speakers. So I'm going to set my speakers to 55, other speakers to 87, and then I'm going to turn them both on. These are just random values just so you can see that they are changing. Then I've added more output down here. So you can see we have a banner for after changes, and then we'll see our output again. Let's go ahead and give this a run. This is the same as before. Our output is exactly the same here. Now, after we called our functions, we can see the volume from the parameterized constructor is now 55, was 30, power is on, was off. And then the same thing for the default constructor. We can see that even though nothing else has changed, the power is currently on and the volume is 87, whereas before it had an empty string and 0. That allows us to modify the speakers. However, currently we're only doing that inside of the program. I'm having to program in the volume and the power. What would be more useful is if an external user who is running the program had the ability to change those values. We're going to do two things next. I'm going to make some functions that are going to allow us to modify those inputs from the user. I'm going to clean this up a little bit. I'm going to put this into functions so I don't have a forever long main method here. And then I think I'm going to go ahead and change up the wireless here so it looks a little cleaner. So instead of having a 1 or a 0, it's going to say true or false. That will be the next steps. I've made some changes, added some functionality to our speaker demo. What I'm going to do is I'm actually going to go down to the definitions first so we can talk about the function, what it does, and then I'll go back to the top of the program. First thing I've added is display information, and I'm passing it an object of type speakers, and you'll notice I'm not passing by reference here, and that's because I just need to get the data out of it, and I don't want to change the data in the current object. I just want to see what it is, so I'm not passing by reference. I just cut and pasted the output text from the main, and I've dropped it in here, so this, anytime I call this function, I can reuse this with one line of code as opposed to having to copy and paste this over and over again. Same thing for separator, same thing for my after banner. These are just functions now, so they're not taking up a ton of space in the main method. I have created this true false convert. All this does is it takes a speaker object and then it checks if it has wireless functionality. If it does, it changes output to true and it returns output. So instead of seeing a 0 or a 1 when we output wireless, we will see true or false, which is just easier to understand. I've added a get user volume, and as you can see, this just asks for a new volume. It takes input from the user and then it returns the volume back to the program. And then I've added get user power state, and I've simplified this a little bit. Instead of allowing the user to type something in, I'm asking them to enter a 1 or a 0, and I'm converting that to on or leaving it as off if they enter a 0. And that's just to make the program a little bit nicer. One thing I do want to point out, I'm not being safe with these two functions because I'm not scrubbing my input. I'm not checking to make sure that the user is only entering an integer from 0 to 100. And I'm not checking down here to make sure that the user is only entering 1 or 0. A user could enter some other data and could cause issues with the program. Something you want to be very careful of when you're writing your own programs is scrubbing data. But just to keep the program fairly simple, I'm not doing that here because it's just a demo. I'm the only one using it, and I'm not going to put in garbage data for testing purposes. Keep that in mind. Those are our new functions. So let's go back up here. You can see I've added them in the function prototypes. And then our main method, we have the constructors as before. Now, however, instead of having all that text typed out, we are going to call the display information. We are going to pass it the mySpeakers object. We're going to display the separator, and we're going to call it again with the other speakers object. Then we're going to call our change functions. What I'm doing here is I'm calling the change volume, and I'm passing it the object mySpeakers. You can see I'm passing a function here. And what happens is the program will have to finish the function inside of the parentheses first before it returns. What happens is whenever you have a function that returns a value, this basically turns into the value. Instead of being a function here, the program is going to see this as whatever value is returned. If I put in 29, this would be mySpeakers, 29, and then change volume will change the volume to 29. Same thing with power state. This is going to be whatever the input or the output is from the get user power state function. Then I'm passing it change volume and change power for other speakers. And here I'm just manually setting them. We can see that there's a difference here. I could call user power and volume to change these at the console too, but just for demonstration, doing it both ways here, displaying the after banner, and then we're going to display the information after these changes have been made. Okay, same as before, it's telling me the speaker information, what it's set to currently. It's asking for a new volume. Let's pick a random number. Let's do 49. Enter 1 for on, 0 for off. I'm going to go ahead and put 1, turn it on. And now you can see after changes, the current volume is on. I'm sorry, the speakers are currently on and the volume is set to 49. And down here we can see the speakers are currently on and the volume is set to 42. We are taking input in this case from the user and modifying it. In this case, we're still just using the end program. We've added a little functionality, made this a little more robust. And again, this is just a simple demonstration of doing classes. And I picked the speakers because it's a simple understanding of we have a blueprint that we define, we build the speakers, and then it becomes an object. And it's the same idea with classes. The class definition is our blueprint, and then every time we instantiate an object in a program, that is our object we have created. I was trying to make an analogy between something real world and tangible, and I've tried to keep it so it makes sense because, for example, when you get a set of speakers, you're not going to change the brand or the model number, and you're not going to be able to change, usually you're not going to be able to change the functionality of that product once you get it. However, if you buy a set of speakers and you take them home and set them up, you can certainly change the volume, you can turn them off, and so on. This was an attempt to be as close to real world as possible and try and make some analogies to help make sense. The last thing we're going to do is we are going to look at creating arrays of objects from a class. Here, I've created 2 objects. Next, I'm going to create an array of objects and show you how you can access each object in an array. What I've done is I have created an array of 100 speakers called lots of speakers. And when this is created, each of the objects in the array are going to be instantiated using the default constructor. Now, before the default constructor, I had everything blanked out, and that's going to be kind of boring and hard to follow. What I've done is I've gone and I've changed the default constructor. I've set the brand to Logitech. See, it's completely new. I've called the model new speaker because I'm super creative and I didn't feel like looking up any actual model numbers. I set the wireless to true, set the volume to max, and the power to on. So as soon as you take it out of the box, it's going to blast your eardrums out and scare the crap out of you. This is our new speaker. Create an array. Every one of these 100 speakers, when it's created, are going to have these settings. I'm doing the same thing as before. I'm calling display information, but you will notice I'm passing it the array with the index of the object I want to work with. We're going to look at item 0, which will be the default constructor. Then we're going to change the volume of element 0. We're going to display the after banner. We're going to display the change here. And then just for fun to show you that it's still independent objects, we're going to look at element 22 and see what that information looks like. Okay, current speaker is a Logitech new speaker, has wireless, current volume on is on and set to 100. Let's put a new volume in. Let's turn down the volume now that our eardrums are bleeding to a more reasonable 35. So now you can see after the changes, the speaker is on and the volume is set to 35. And then this is element 22, and you can see everything is still exactly the same. So again, we're working with individual objects. Okay, that wraps up our overview of classes in C++ and the different ways that we can work with objects that we create from the class. Again, this is a bit of a silly example, but it's meant to be simple and easy to follow. And while obviously we're not going to build real speakers inside of a computer program, we're going to build them in a factory and sell them. Imagine this was for a computer game. Perhaps in a game, I have a set of speakers that the player, the user, can interact with in the game and actually turn them on and off and turn the volume up and down. Now, there would need to be a lot more that went into this, but you sort of have a skeleton of an idea here of how you could implement that and have an actual speaker class that would make sense.